Hi, welcome back to the online video lecture. Now we'll see the next point, that is the Bluetooth. Ideas of the Bluetooth is universal radio interface for the ad hoc wireless connectivity. Bluetooth is the wireless personal area network WPAN technology. It is based on the IEEE 802.15.1 standard. Bluetooth provides the short range, low cost connectivity between the portable devices. Bluetooth is limited in range, so that is less than 10 meters, and provide the speed of about 780 kbps. Thus, the Bluetooth is used as the replacement for the cable and wired network to form a small ad hoc private wireless LANs. Now, which are the local area networks? So, limited for the coverage and without the need for infrastructure. Now, this is the different type of network is needed to connect the different small devices in close proximity, means about 10 meters only. Now, without expensive wiring or the need for the wireless infrastructure, right? So the necessary component should be cheap in case of cost is considered, and the goal is provide the network so within the less range, right? So nowadays the devices offers and infrared data association, IRDA interface, or replacement of the connecting computers and peripherals, handheld devices, PDA, cell phones, and replacement of IRDA, right? So here there are various problems with the IRDA, so it is a very limited in range. So the need for the line of sight between the interface and it is usually limited to two participants, so only point to point connections are supported. If we consider about the IRDA, has no in IRDA or infrared has no internet working functions, has no media access or any other enhanced mechanisms. So the big advantage of the IRDA is its low cost and it can be found in almost any mobile, laptop, PDA or mobile phones, right? Now these are the in the image, so how the Bluetooth is accessing all the wireless devices. One of the first model that is developed by the Ericsson company is shown here in the diagram. Now we'll see about the history of the Bluetooth, right? The Bluetooth start in 10th century, so when Harold Gormans, sorry, Gorsman, Gormsen, king of the Denmark or son of the Gorms, so erected a run stone in the Jelling in Denmark, so in the memory of his parent, and the stone has a three side with elaborate carvings. One side shows a picture of Christ, and as the herald did not only unite the Norway and Denmark, so but also brought the Christianity to the Scandinavia, and the Harwald had the common epithet of the blatant, meaning that he had a rather dark complexion or not a blue tooth. Now it took the 1,000 years before the Swedish IT company Ericsson Limited. Some studies in 1994 around so-called multi-communicator links, right? and the project was renamed. So and the Bluetooth was born, right? So in spring 1998, the five companies Ericsson, so special interest group, that is that five companies. The first one is the Ericsson, Intel, IBM, Nokia, Toshiba founded the Bluetooth, right, with the goal of the development of the single chip with the low cost radio based wireless network technology. Now again, the many other companies and the research institute also joined the special interest as with their special interest. So groups around the Bluetooth in 2020. So that groups now becomes up to more than 2,500 members of the groups, right? Now, the whose goal was the development of the mobile phones, laptops, notepads, headset, etc., including the Bluetooth technology. Now, by the end of the 1999, so in 1999, the Ericsson erected Run Stone in Sweden in memory of the Harald Jorsson, so called as a Blatant, and who gave his epithet for this new wireless communication technology. And this now new carving shows the man holding a laptop and now here the man. So this is the carving man, the holding a laptop and the cellular phone in his hand, and a picture is quite obtained or cited. Of course, there are no such things visible on the original stone. That is just a nice story, right? So here it is shown in one hand laptop and in other hand the cell phone. So in 2001, the first product hit the mass market, and the many mobile phones, laptops, PDA, video camera, etc., are equipped with the Bluetooth technology today. Now, at the same time, the Bluetooth development started, and a study group within the IEEE 802.11 also started. That is the wireless personal area network under the some criterias. So that is the market potential, by considering the market potential, how many application devices, vendors, customers are available for certain technology, and capabilities with the IEEE 802. Distinct identity means originality, or the study group did not want to establish this second IEEE or 802.11 standard. However, the by considering the low cost, low power, or the small form factors are not addressed in the 802.11 standard, right? So technical feasibility. So again, the protocols are necessary for the further. In the further slide, we'll discuss about the protocols, right? So technical feasibility also checked. Again, economic feasibility is also considered, and the Bluetooth is invented, right? Or production of the Bluetooth is started in mass market, or first product hit in the 2001. And also this group, so whatever the group is created here, by considering the so many companies, right? So initially they developed the communication with personal operating space, right? POS or IEEE, right? And the radius initially has been the radius is defined of 10 meters around the person in which a person or the device of the personal communicate with other devices, right? So that initially the range of that device is only 10 meters. Right, after that we will discuss the next characteristics. So 4 gigahertz ISM bands, 79 RF channels 1 megahertz carrier spacing. Now here channel 0, so 2402 megahertz, and channel 78 also using the 2480 megahertz, right? So GFSK modulation is used. Now 1 to 100 megawatt transmit powers, right? So here frequency hopping, sequence spectrum, and time division duplex is used. So here frequency hopping with 1600 hops per second. Now hopping sequence in pseudo random fashion determined by a master. The time division duplex for send or receive separations, right? Next, voice link. Next characteristic, voice link. So synchronous connection oriented, right? So forward error correction, no retransmission, 64 kilobit per second duplex, point to point circuit switch. So these are the voice links. And data links. So in the data link, asynchronous connectionless, asynchronous fast acknowledges, point to multicast up to 433.9 kilobit per second, symmetric, or 723.2 oblique 57.6 kilobit per second asymmetric packet switch. And the topology is used, that is the overlapping piconet stars forming a scatternet. Now the meaning of the piconets and scatternet we'll discuss in the next slide. Right, now next part of the Bluetooth we'll discuss, that is the piconet. A very important term in the context of the Bluetooth is piconet. The piconet is the collection of Bluetooth devices which are synchronized to the same hopping sequence. Now here the figure shows a collection of devices with different roles. Now here so many devices are there with their different roles, right? One device in the piconet can act as a master, so M will act as a master, right? And all other devices connected to this master must act as a slave, and slave is denoted by using the S. And the master determines the hopping pattern in the piconet, and slave have to synchronize to his pattern, right? And each piconet has a unique hopping pattern. So every piconet is having their unique hopping pattern. If device want to participate, it has to synchronize to this, right? So two additional type of devices are shown here. One is the parked device, so that is cannot actively participate in the piconet, that is they do not have the connection but are known and can be reactivated within some milliseconds. And another device, that is the SB standby, or you can call them as a standby, SB standby. So do not participate in the piconet. So this SB do not participate in the piconet. Now in the diagram it is shown by using the SB in green color. Right. Now here each piconet has exactly one master. So one master and up to 7 simultaneous slaves. So more than 200 devices can be parked maximum, right? And the reason for the upper limit of the 8 active devices. Now is a 3-bit address is used in the Bluetooth, right? So if parked device want to communicate, and their address used in the Bluetooth, right? So the park device means it is represented by using the P. If parked device want to communicate, and there are already 7 active slaves, and one slave has to switch to park mode to allow the park devices to switch to active modes, right? So this is about the piconet. Now we'll discuss the next how to form the Bluetooth piconet, right? Or forming a Bluetooth piconet. Forming a piconet for the Bluetooth, right? So here the in the diagram, in both diagram, the theory of the formation of the piconet is shown. So as all active devices has to use the same hopping sequence, they must be synchronized. So all the active devices, they need to use their same hopping sequence. The first step involves the master sending its clock and device ID. So master will create their device ID and clock, and this master will the sending its clock and device ID. All Bluetooth devices have the same networking capability. That is, they can be master or slave. There is no distinction between the terminal and the base stations. Any two or more devices can form the piconet. Now, as we know, so more than two devices can form the piconet, right? And the unit establishing the piconet automatically here becomes the master. So all other devices will be slaves, and the hopping pattern is determined by the device ID, right? So this hopping pattern will be determined by using the device ID 48 bit. Now 48 bit worldwide unique identifier is used, and the phase in the hopping pattern is determined by the master clock. Now after adjusting the internal clock according to the master device, so may participate in the piconet, right? And all active devices are assigned 3-bit active member address, right? So addressing is done here. Active member address is assigned, that is of 3-bit, and all parked devices use an 8-bit parked member address, right? So devices in the standby do not need the address, right? Now here all user within the one piconet have the same hopping sequence and share the same 1 megahertz channels. And as more user join the piconet, the throughput per user drops quickly. So if more than limit, if the user want to join the piconet, so obviously the throughput per user drops quickly, right? And this leads to the idea of forming the group of piconets called as a scatternet. Now by considering these drawbacks, so if the number of user is getting increased, so throughput per user drops quickly. So by considering a single piconet, now by considering this idea, so again the new concept is introduced, the forming the group of piconet, so called as a scatternet, right? Now here in the figure, the scatter diagram of the scatternet is represented. Now two piconet is shown here, right? And for two piconet, two masters are there, right? And slaves. Now here the one slave is used as common in both the piconet, right? So scatternet means the forming the groups of piconet is called as a scatternet. Now only those units that really must exchange the data and share the same piconet. Sometimes the piconet overlapping by considering the coverage, so or simultaneously they will work access the data, right? So as an example, if we consider the scatternet consists of two piconet, now we'll consider this example. in which the one device participate in the two piconet. Suppose one device want to participate in the two piconet, both piconet use the different hopping sequence, right? And always determined by the master of the piconet, and Bluetooth applies the frequency hopping CDMA for separation of the piconet. Now, in an average sense, all piconets can share the total of 80 megahertz bandwidth available. Now, adding more piconet leads to the performance degradation of the single piconet, right? So because more and more collision may occur, right? And a collision occur if two or more piconet use the same carrier frequency at the same time. So this will probably happen as the hopping sequence are not coordinated properly. Now, if device want to participate in more than one piconet, right? So device want to participate in the more than one piconet, it has to synchronize to the hopping sequence of the piconet it want to take part in, right? Or if a device act as a slave in one piconet, it simply start to synchronize with the hopping sequence of the piconet it want to join. Now, after synchronization, it acts as a slave in this piconet and no longer participations in its former piconet. Now, to enable the synchronization, the slave has to know the identity of the master that determines the hopping sequence of the piconet. Now, before leaving one piconet, a slave informs the current master that it will be unavailable for a certain amount of time, and the remaining devices in the piconet continue to communicate as usual, right? So this is about the scatternet. Now, in case a master can also leave its piconet, what will happen and act as a slave in another piconet? So it is clearly not possible for the master of one piconet to act as a master of another piconet, as this would lead to identical behavior. So one master will not occupy the place of master in another piconet, right? So identical behavior will happen. So as soon as the master leaves the piconet, so all traffic within this piconet is suspended until the master returns, right? So communication between the different piconet take place by the devices jumping back and forth between these nets. Now, if this is done periodically, for instance, right? So data streams can be forwarded from one piconet to another, and Scatternets are not yet supported by all the devices. So this is about the Scatternet forming a piconet and how the piconet is created, or meaning of the piconet. Now, the next very interesting part of the Bluetooth is the Bluetooth protocol stack. Now here the figure shows the Bluetooth specification. So already include the many protocols and component. Now starting with the simple idea. Now it now covers over the 200 pages dealing with the not only the Bluetooth protocol but many adaptation functions, so an enhancement. The Bluetooth protocol stack can be divided into core specification, so which describe the protocols from physical layer to the data link control together with the management function, and the profile specification, right? The latter describe many protocols and functions needed to adopt the wireless Bluetooth technology, that is to the legacy and new applications, right? Now we'll discuss about the core protocols of the Bluetooth, which includes here, that is the radio, baseband, link managers, and logical link control and adaptation protocol (SDP). So here it is in the diagram. It is shown by using the orange colors, right? So first, radio. So specification of the air interface is done by using the radio, that is the frequencies, modulation and transmit powers. Next one is the baseband. So description of the basic connections, establishment, packet format, timings and basic quality of service parameters, right? And next one is the link manager. Link setup and management between the devices, including the security functions and parameter negotiations, right, is done by using the link managers, right. Logical link control and adaptation protocol L2CAP. So adaptation of the higher layer to the baseband is done connectionless and connection oriented services. SDP means service discovery. So discovery protocol. So device discovery in close proximity plus querying of service characteristics, right. Now on the top of L2CAP is the cable replacement protocol, that is the RFCOM. So that emulates a serial line interface. So following the EIA 232 standards, right. So this allows for simple replacement of the serial line cables and enables the many legacy application and protocol to run over the Bluetooth. So RFCOM supports the multiple serial port over a single physical channels, right. The next one is the telephone control protocol. Telephony control protocol specification binary TCS bin. So that TCS bin describes a bit oriented protocol that defines call control signaling for the establishment of voice and data calls between the Bluetooth devices. Now it also describes the mobility and group management functions. Next, host controller interface, HCI. So between the baseband and L2CAP provides a command interface to the baseband controller and link manager and access to the hardware status and control register. And the HCI can be seen as the hardware or software boundaries. So many protocols have been adopted in the Bluetooth standard. Now classical internet applications can still use the standard TCP/IP stack running over the triple P, or use the more efficient Bluetooth network encapsulation protocol, Bluetooth network encapsulation protocol. Now telephony apps can use the 80 modem commands as if they were using a standard modem, right. Now calendar and business card objects. So here it is represented VCal or B card. So can be exchanged using the object exchange protocol, OBEX, object exchange protocol, as a common with the IRDA interface, right. And a real difference to other protocol stack is support of audio and audio application may directly use the baseband layer after encoding the audio signal. I hope all of you understood the Bluetooth protocol stack. Now here the Bluetooth concept is complete. Thank you.
Hopefully you might have enjoyed the lecture. Then please do like the video and know your thoughts in comments. Please do share this video among your friends and don't forget to subscribe to our channel. After subscription you can press the bell icon to never miss the notification regarding our new videos. Thank you so much.